Let's understand satellite technology based on orbit distance. What is the satellite technology based on orbit distance? Satellite technology can be categorized based on the altitude of the satellite's orbit around the Earth. The three main categories of satellite technology based on orbit distance are low Earth orbit (LEO) satellites. LEO satellites are positioned in low Earth orbit, typically at an altitude of 2,000 kilometers or less from the Earth's surface. LEO satellites have a relatively short orbital period and are used for applications such as communication, navigation, and remote sensing. Medium Earth orbit (MEO) satellites. MEO satellites are positioned in a medium Earth orbit, typically at an altitude between 2,000 and 35,786 kilometers from the Earth's surface. MEO satellites are primarily used for navigation applications such as GPS and provide coverage over a larger area than LEO satellites. Geostationary Earth Orbit (GEO) satellites. GEO satellites are positioned in a geostationary Earth orbit at an altitude of approximately 36,000 kilometers from the Earth's surface. GEO satellites orbit the Earth at the same rate as the Earth's rotation, which allows them to remain in a fixed position relative to the Earth's surface. GEO satellites are primarily used for communication applications such as satellite television and telephone services. Each type of satellite technology has its unique advantages and disadvantages and is used for specific applications based on its orbit distance and capabilities. What is low Earth orbit satellite technology? Low Earth orbit (LEO) satellite technology is a type of satellite system that is positioned in low Earth orbit, typically at an altitude of 2,000 kilometers or less from the Earth's surface. LEO satellites are used for a wide range of applications, including communication, navigation, remote sensing, and scientific research. One of the main advantages of LEO satellites is their low altitude, which allows them to provide high-speed data communication with low latency. This makes LEO satellites particularly useful for applications such as satellite internet and mobile communication, where low latency is essential for providing a seamless user experience. LEO satellites are also used for navigation applications such as GPS, which rely on accurate positioning information from a network of satellites in orbit around the Earth. Additionally, LEO satellites are used for remote sensing applications such as weather forecasting, environmental monitoring, and surveillance. One of the key features of LEO satellites is that they have a relatively short orbital period, typically between 90 minutes and 2 hours. This means that they move quickly across the sky, and as a result, a network of LEO satellites is required to provide continuous coverage over a given area. In recent years, there has been a growing interest in LEO satellite technology, particularly in the provision of satellite internet services. Several companies, including SpaceX, OneWeb, and Amazon, are currently developing or deploying LEO satellite constellations for this purpose. What do you think is the commercial situation for LEO technology? The commercial situation for low Earth orbit (LEO) technology is currently very dynamic and competitive, with several companies investing heavily in the development and deployment of LEO satellite constellations for various applications. One of the main drivers of the current commercial interest in LEO technology is the potential for providing global satellite internet services. This has led to the emergence of several new players in the market, such as SpaceX's Starlink, OneWeb, Amazon's Project Kuiper, and others, who are all working to deploy large constellations of LEO satellites to provide high-speed internet services to users around the world. In addition to satellite internet, LEO technology is also being used for a wide range of other applications, including navigation, remote sensing, and scientific research. For example, companies such as Planet Labs and BlackSky are deploying LEO satellite constellations for remote sensing applications, while the European Space Agency's Galileo constellation provides navigation services for Europe and other parts of the world. While the potential for LEO technology is significant, there are also several challenges that must be overcome to make these systems commercially viable. These include the high cost of launching and maintaining large constellations of satellites, the need for sophisticated ground infrastructure to support these systems, and regulatory challenges related to spectrum allocation and interference. However, the rapid pace of technological development and the growing demand for satellite-based services suggest that the commercial prospects for LEO technology are likely to remain strong in the coming years. Thank you for watching. If you haven't already, please subscribe to my channel so you don't miss out on any of my future videos.